Hey gang, this is a section that'll be a little more familiar to you. We're going to start solving systems of equations. We'll be solving two equations with two unknowns, and then we'll be heading into three equations with three unknowns. So let's look at this situation for a minute. I know this looks good, right? Heading towards summer. It looks very nice as we're actually heading into winter. But let's pretend that we are thinking about either buying a pool membership for $90, which will get us in and anytime we want all summer long. But we will then pay $2 each time for a lawn chair. Okay, so we do like to have our lawn chair. You are deciding whether to do that or run down to Target and buy a lawn chair for 15 bucks. And then you would just pay every time you go, which is $7. We want to know which is the better deal. Okay, so of course we would write two equations. Our choices are we spend $90 and then we spend $2 each time for a lawn chair. Okay, that's one option. $90 is a once and done thing. And then if X is how many times we go to the pool, I have to take 2 times that. So let's say I go 5 times to the pool. Then I've spent, I've gotten a lawn chair 5 times. That's 10 bucks there plus 90, 100 bucks I've spent, right? Other option is we decide, you know what? I am just gonna go down, get a lawn chair for 15 bucks and then pay $7 each time, which is the entrance fee. Okay, so then if I go 5 times, 35, 45, then I'm gonna spend 50 bucks. Okay, you've gone 5 times and spent 100 bucks. This guy's gone 5 times and only spent 50 bucks. Which is the better deal in the long run? One way to understand that would be to graph it. Okay, we could graph the 90 plus 2x, which of course we know how to do that. We go to our y-intercept of 90. And what did I say? If we went 5 times, we spent 100 bucks, right? 5 times 2, yeah. Okay, and then we would graph, here we go. There's every single scenario, up to 20 times. Okay, the other option was, hey, maybe we just go and spend $15. And then we spend $7 a time. So I said if we went 5 times, that was 50 bucks, I think. Okay, so let's see where that puts us. Whoa. There's that. I'm trying to get to 20. Okay, I'm going. All right, something like around like so. Okay, so we want to know which is the better deal. Well, here's our point where we spent the same exact amount of money. After 15 times, it looks like no matter which option we did, whether we got the lawn chair and spent $7 a time, or we spent the 90 bucks for the membership and got the chair each time. Okay, if I go 15 times, I've spent $120. This time, 15 times 2 is 30, plus 90 is 120. This one, 15 times 7 is 85. Or 15 times 7, I'm sorry. Wait, how much did I say? 120, yeah. So 105 times plus 15 is 120. All right, either way, sorry. So we're wondering what the better deal is. And in this case, it would be, it depends. Depends how many times you're going to go to the, at least we know this point, this breaking point, this 15, this break-even point, okay, where we're both have spent the same. If I think I'm going to go more than 15 times, I'm going to get the membership. So I'm going to break down my summer, think about how often I have to work and blah, 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 and see if I actually am going to get to the pool 15 times or not. Okay, and if I am going to get there more than 15 times, I'm going to get the membership. If I'm only going to go 10, 11 times, I'm just going to pay each time. Okay, so to solve a system of equations, one way you can do that, as you saw, was to graph. Okay, so here we have 2x plus y equals negative 3. So y equals negative 2x minus 3. I'll go down here to negative 3, which is my y-intercept, down 2 into the right one. I think I'll go up 2 into the left one, if that's all right. Running out of room there. Okay, there's that nice line. Okay, so I either have that or the other one. Oh, not the nicest y-intercept, is it? Y equals 2/3 x minus 13/3. So I'm going to go down here to negative, what's that, 4 1/3? Negative 4 1/3. And my slope is positive 2/3. So I'm going to go up 2/3. Okay. I was at 1, 2, 3, negative 4 1/3, just a little bit under there. Yeah, so up 2/3. It looks pretty good. Alrighty. So we'll graph that. Problem is this time a little bit hard to see what that point is, you know, where they intersect. Is that about a half or 3/4? I don't know. Okay, so I'd have to look and see what that is. If I put a half in here, that gives me negative 4. And if I put a half in here, that gives me 1/3 minus negative 12/3. Yeah, that gives me negative 4. So it looks like that was a little bit cumbersome to see, but a half negative 4. As what I'm trying to show you is that graphing has its limitations. First of all, we have to have a sheet of graph paper all ready to go. And second of all, sometimes those fractions are hard to see. Another way we can do this is something called substitution. You take what y equals and you put it in for y in the opposite equation. Okay, you always have two equations. So whichever one is solved for one of the variables, you take that expression and put it in for the other variable. If y equals 2/3 x minus 13/3, then everywhere I see y, I should substitute in 2/3 x minus 13/3. So I'm going to substitute that in. Okay, so instead of 2x plus y equals negative 3, since y and 2/3 x minus 13/3 are the same thing, where the y is, I'm going to just put a 2/3 x minus 13/3. So we combine like terms. 2 plus 2/3 is 2 2/3, or 8/3. And then, of course, I'm going to add 13/3 to both sides. So I get 8/3 x equals, what's that, negative 9/3? That'll be 4/3. Okay, I'm taking negative 3 is negative 9/3. Negative 9 plus 13 is 4. I'm going to multiply by 3/8 to get rid of that. And look what we get. 4/8, or a half, which we knew it was a half, right? Because I just graphed it. But that's okay. That's the x coordinate. Great. A half what? To find the y coordinate, I'm just going to put a half in for x. In which one? Either one. That we're saying this is the point where they intersect. So it doesn't matter which one, I'll get the same y value. So I'm going to put in here because it already says y equals. So I'm just going to put 1/2 right here. That gives me 1/3 minus 13/3. That's negative 12/3, which is negative 4. Okay, so that's another way to solve a system, something called substitution. Elimination by addition, notice I'm using the same one here. Elimination by addition, we have to line up our x's and y's. So we want everything in standard form. I'm going to take this 2/3 x and subtract it and bring it over here with the y. Okay? And then what you want to do, ideally, is you'd like to add these together, and you want either the x's to add to 0 or the y's to add to 0. And right now, neither of those do that. So I'm going to multiply everything by a -1 in this case, because if this was a negative y, that'd be awesome. Then everything would cancel out. Well, I can't just make this a -y, but I can multiply both sides of the equation by -1, making this a positive 2/3, a -1y, a positive 13/3. I don't know why I wrote 13/2. Okay, now let's add those together. 2 plus 2/3 is 2 2/3 x. These cancel, that's why I multiplied by -1, equals -9/3 plus 13/3 is 4/3. So what's that? That's 8/3 x equals 4/3. Multiply both sides by 3/8. You're seeing the parallels here, I'm sure. You get x is 1/2. Again, that only gives me my x coordinate. I want the whole ordered pair where these two lines share. So I'll put 1/2 in. Of course, I get 1/3 minus 13/3, which is -4. Okay? Those are our 3 ways to solve a system. Sometimes there's just one way that's best. That's all I can tell you. It doesn't mean it's the only way, and some people just latch onto a way. Like I just use elimination by addition no matter what, or I use substitution no matter what. But try to get out of that a little bit. Understand both ways and understand that, hey, this guy looks like I almost have the x's and y's lined up. You know, if I just flip these around, let me just rewrite the 2x plus y. But I'm going to write -x plus y equals 5. All right, this is the same as y minus x, right? And then it's just a very quick fix to multiply everything by a negative and add. 3x equals -6, x is -2, right? -2 what? Well, I'd have to put -2 in for x. Y minus -2, that's y plus 2. Subtract 2 from both sides. It looks like -2, 3. I usually check it and make sure then if I put -2, 3 in, do I get -1? That's -4 plus 3. Yes, I do. Now this one, I'm not going to use elimination by addition. It already says y equals. If they're telling me that y equals -3x, then put -3x in for y in the other equation. It's so quick. Substitution is so quick when you already have a letter, solved for. So this gives me x plus 6x equals 7. 7x equals 7, so x is 1. All right, and what's y? Well, -3 times 1, -3. I'll double check that 1 -3 works here. 1 minus -6, that's 1 plus 6. Yep, that's 7. Okay, so in this case, I would argue that, of course, you can do it with substitution. You could solve one of these and go, fine, but it's already basically lined up x's and y's. This one, yes, you could use elimination by addition. Maybe you'd add 3x over here and set it equal to 0, but why when it's already ready for substitution? Try to use them both. Okay, solve these, and then let's come back and see how how everybody did it. Pause me, please. Okay, so hopefully you use substitution for the first one and just stuck the -2x plus 6 in here. But interestingly enough, what happened here, guys? The x is canceled, right? We have 12 equals 8. 12 don't equal 8 in my book. So no solution. Opposite thing kind of happens here. I rewrote the first expression, took the x over to the other side, and I add these. I get 0 equals 0. Well, yes, it does every day of the week. So this is infinitely many solutions. Come back for part 2, okay? I have to explain this. All right, thanks.